Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Motion. Today we will learn about acceleration. So we learned about motion, body in motion and at rest, and also we learned about speed and velocity and distance and displacement before that. So we know that when a speed is in a particular direction, so we call it as velocity. If equal distance is covered in equal intervals of time, then we call it as uniform velocity. But most of the time, the velocity is variable velocity. So how can the velocity be variable? That is, even if it is going in the same direction, but it keeps changing its velocity, right? Or even the velocity is the same, but it keeps changing the direction, or both. So in all these situations it can happen, but most of the bodies, when they are moving, they are actually changing their velocity. So the change in velocity over a period of time is called an acceleration. So it can be increasing or decreasing. So usually if the speed is increasing, that means velocity is increasing, we call it as positive acceleration or just acceleration. So we can say that it is the rate of change of velocity with respect to time. So we can say that acceleration A is equal to final velocity, means the velocity has changed, minus initial velocity. That is the change in velocity we can say upon time. So A is equal to, what is the symbol for final velocity? V, minus initial velocity is U by T. So this is the equation for acceleration. Now let's see what is the unit of this. So we know that here we are representing velocity in the numerator. So the velocity is meter per second, right? Upon again second. So what will we get? Meter per second square, or m s to the power of minus 2. So this is the unit of SI unit of acceleration. So we know that when the velocity is increasing, that is called a positive acceleration. For example, a freely falling body under gravitation, it keeps increasing in velocity. Actually that is a constant. 9.8 meter per second will be the acceleration due to gravity. So that is also a positive acceleration. But imagine a car is moving at a speed of 120 km per hour, but we are applying brake. So the car is decreasing its velocity and coming to a halt. So in this case, the velocity is decreasing, then we can call it as negative acceleration, or it is otherwise called a deceleration. This can also be called as retardation. There are two examples we can tell in this regard. First of all, when we are throwing a ball up, initially we are throwing with a particular velocity, but you know that it slows down, it decreases and it reaches 0, then it starts falling down, right? So while moving up, it is retardation happening. The same way, if I roll a ball on the floor also, we cannot expect it to roll indefinitely, right? It will slow down and come to an end. So here also what is happening? The negative acceleration, or we call it as retardation. Now, acceleration can be uniform acceleration also. What is meant by uniform? We learned about uniform motion, we learned about uniform velocity. That means the velocity increases in equal amount at equal intervals of time, then we call it as uniform velocity. For example, maybe first 10 minutes it is going at a speed of 10 meters. Okay, next 10 minutes it is 20 meters. Next 10 minutes it is 30 meters. So the time frame is the same here, but the velocity is increasing 10 meter per second. It's meter per second, okay? Meter per second every interval. So this is equally increasing. So it is called a uniform acceleration. A typical example of this is again a freely falling body, because I told its velocity is increasing at a constant rate, 9.8 meter per second. And also through an inclined plane a ball is moving, then that also will show some kind of uniform acceleration. But think about a car moving on a straight road, or an auto rickshaw or a cycle. we know that at different times they increase or decrease their velocity. For example, when there is no traffic, they may go at the maximum speed limit, and when there is a signal comes, they will come to a halt. Again, they start accelerating the vehicle, but if the traffic comes again, they slow down. So this way the velocity is not remaining constant, it is decreasing. So if the velocity is different at equal intervals of time, then we can call it as what? Non-uniform acceleration. But there are certain cases where there can be zero acceleration. That means we know velocity change is acceleration. That is, change in velocity is acceleration. But if there is no change in velocity, for example, if a car in the initial time when we are noting down, the car is going at a 80 km per hour. After 10 minutes, again it is 80 km per hour. Again 80 km. So till we make note of, it is 80 km per hour. So is there any change between the final velocity and initial velocity? No. Final is also 80 km per hour. Initial is also 80 km per hour. So in this case, zero, right? So this can be called as zero acceleration. That means when there is no change in the velocity or the velocity is constant, then we call it as zero acceleration. We will be solving a few numericals in this regard, but always keep in mind these 3 points. That is, if you are doing a problem where the body is starting from rest, okay, so the initial value, that is initial velocity u, is taken as 0 in this case, if the body is moving from rest. The same way, if it is going at the speed of 80 km per hour, but it is stopping at one point. So here stopping, so what is the final velocity? 0. So v should be taken as 0 in such cases. But if in the question, if they are giving the vehicle or the body is moving with a constant velocity, if that is the case, then acceleration will become 0. Let's now solve a numerical based on this. A bike moving at a speed of 72 km per hour. After 10 seconds, the velocity becomes 90 km per hour. Assuming the velocity change took place at uniform rate, find the acceleration. So if it is at uniform rate, usually we consider that scenario. We know that acceleration is equal to final velocity minus initial velocity upon time. Right? So here we have all the parameters given. Initial velocity is given as 72 km per hour. Okay? Time given is 10 seconds. And final velocity is a v. So if you substitute these values, we can get the answer. But here one problem, whenever we are doing such problems, the answer should be in SI unit. But here it is given in kilometer per hour. You know that 1 kilometer is 1000 meters. Okay? And the SI unit of time is second. So hour means what? 60 into 60, 3600 meters. So if you are solving this, or if I write 60 into 60, 3600 meters or 3600 seconds is the 1 hour. So if you solve this, you will get, this is 5, this is 18, if you solve with the 2. So if you multiply kilometer per hour with the 5 by 18, you will get meter per second. So u is equal to 72 into 5 by 18. So 18 4 times 20 meter per second, whereas v is equal to 90 into 5 by 18. This will go 5 times, so 25 meter per second. Now we can substitute these values. 25 is the final velocity minus initial velocity 20 upon time 10 seconds. So what is the answer? 5 by 10. 1 by 2. 0.5 meter per second square is our acceleration. So the next question is, a car moving with a speed of 36 km per hour is brought to a rest within 10 seconds by applying brakes. Find the retardation due to brakes. So here retardation means what? Negative acceleration. So A is equal to V minus U upon T. Here we know that the car is initially moving with a speed of 36 km per hour. So U is taken as 36 into 5 by 18 because we have to convert it into SI unit. So 10 meter per second. What is V? It is brought to rest. So final velocity is 0 in time 10 seconds. So we will substitute 0 minus 10 upon 10. So minus 10 by 10 minus 1 meter per second square. So retardation means about negative acceleration. So it is 1 meter per second square is the acceleration in this case.